and organizations and mechanisms that can sustain over time. The one in particular I would draw your attention to is Koali, and I'm just curious, how many of you even heard of or know anything about something called the Koali Project? So maybe about half of the audience. This project is essentially writing administrative system software. So hopefully over time, your university won't pour hundreds of millions of dollars into PeopleSoft and SAP and other things like that, and will be in the smaller millions of dollars to migrate to an open source enterprise system for your student or financial system, research administration, things like that. But it has involved putting together a large virtual organization, building software that can travel to different kinds of institutions. So in putting the first one together with Koali Financial Project, and I'll talk more about it later, we had 6 institutions come forward from the beginning and agree to put cash and staff time in to develop a system. And there were a few things that I think were interesting about that helped guide it along the way. We had many colleagues who said, look, if you guys want to do Sakai and you want to dabble in teaching and learning software, okay, that's amusing and that's good, and maybe you'll be a competitor to Blackboard. But my God, man, this is a financial system. And, I kind of took pause at that and said, you got to be kidding. So from a design requirements basis, a teaching and learning system, you've got hundreds of thousands of faculty who all know the way teaching should be done. But with a financial system, at least you've got some rules. There are some accounting requirements, debits should add up and equal credits and things like that. And so the requirements actually were, I think, easier than trying to do a teaching and learning system where the world's constantly evolving and everybody wanting to do lots of different things. But we run into all sorts of crazy stuff. So my friend here from Cornell, being a public and private institution, depending on which personality you have at that moment. And we have state laws, in how California has to do things versus how Arizona does things. But one of the things that we did learn to do miraculously was to come together and work on what the requirements would be on a pretty aggressive timeline and build the software to broad requirements early on from the beginning. And I think that's an interesting observation because a lot of times when we're working with software, we're often starting from a very localized project need, and then we're trying to generalize it to the world, and we realize the world says, but, it needs this and that. So we've got some experiences in these things, and particularly for Koali and Sakai, we're out of grant money a long time ago. So those projects are already on the other side of what we'll talk about as the chasm a little bit. My friend Mackenzie's here with DSpace, and she created DSpace with her colleagues, and they've been out of grant phase for a long time. So just looking around the room, I'd like to get a head count. How many of you have been closely involved in building some software that has traveled and been adopted elsewhere? How many of you have been closely involved in something like that? So most of the room, you've been through that in some way. How many of you have been involved, or maybe I should say are currently still involved in a software project that it's out of money? It's out of magic money from NSF, it's out of magic money from foundations, and you're out there sustaining that software for a community through some other means. Looks like about half of the hands that went up a moment ago. So I think one of the things that we hope to accomplish in this workshop is to talk about what lessons can we learn from different communities. There may be some models, there may be some approaches that are transportable across different kinds of projects as we go. So I lead off with this quote, which I absolutely love. This is written as a letter to the New York Times. I have thanks to our wonderful folks in libraries, there's the actual letter to the editor written by President James Bryan Conant, president of Harvard University. This follows a response to someone who commented on Vannevar Bush's proposal of Science, the Endless Frontier, as you know, that was instrumental in the creation of the National Science Foundation. And notice the assertion here. If you really want to advance, there's only one proven way of advancing real science. Hire men, I think he meant men and women, of genius, back them heavily, and leave them the hell alone. Well, that notion of advancing science, there may be elements of it still true today, but it's also given way to a new way of thinking about it. With the 2003 report on cyber infrastructure, and then the successor, follow-up 2007 report, noticing the argument is that real science is not going to advance by someone in an isolated lab left the hell alone, but probably going to advance through new means of collaboration, new organizations, new instruments at scale, new software tools at scale, this notion of cyber infrastructure that we're talking about here today. But we find ourselves kind of stuck in a classic cartoon at the moment, that this ad hoc collection of research projects hasn't necessarily yielded cloud computing, cyber infrastructure nirvana yet. So I think in this workshop, we're trying to get just a little bit more explicit about step number 2 on the software artifact itself. The two words that come to mind, and I like Gerhardt's notion bringing up roads and bridges a moment ago. We understand the first part here, the cyber, relating to computers, and we understand the part about infrastructure. There's a lot of talk right now in the U.S. in terms of billions, hundreds of billions of dollars being pumped into what's shovel-ready infrastructure. I don't know if you consider your software development shovel-ready or not, unless you're using a shovel to motivate your graduate students in some way. But we understand this notion of, I thought that was interesting, the notion of public works, and also the concept required for inactivity. So as we think about software, just to echo Jennifer's comments, I think what we're saying is we've got to get serious in thinking about software just as much as we think about buying hardware or a telescope or an MRI program. It is an essential element of cyber infrastructure, but as an artifact, it's a troublesome artifact. And the reason it's troublesome is if we build a building and you don't particularly like where one of the windows was put, you know, it's probably just tough cookies for you. You don't get to go change the window. It's physically there. Or if a road goes around a block in the wrong place, we just learn to live with it. But with software, the cost of entry is pretty darn low in terms of at least being able to have the tool. Not that you know what to do with the tool and coding and such, but we can make changes. We can make changes very easily. And I can argue that why are you using such and such specification, that crap stuff from the Apache Foundation that's not mature? Look, here's something better. My framework is better than your framework. And so we end up in this endless tweaking around with no real means of ever settling it down sometime. And then the guy wants to drive the minivan, as you said. You know, the road doesn't have to be perfect in one way or another that it's optimized, but it does have to be there and it has to work. As we look across disciplines, and this is where my view, I'm a business school professor, and I think a lot about industries and multiple disciplines. I've had this conversation with some thinking about building out these research stacks. And these stacks have some stuff that's common, and they have some stuff that really needs to be unique and specialized and innovative and let people do whatever seems cool for solving their problem of the day. So if you'll work with me in using this just as an abstraction. So if we were to take genomics and research in life sciences, there are a set of things that they need to be able to use. And so networks, computation, storage, curation, all of this, and a lot of innovation and smart people at the top. Well, other disciplines, whether it's physics or anthropology or even the performing arts, they each have a stack of things that they need as well. But what we see prior to thinking about cyber infrastructure, and in some cases still at the campus today, as each discipline says, I need a new 2 or 3 petabyte or 10 or 20 petabytes of storage, and I need a new cluster to do this. And oh, we're starting to put a lot of data together. God, it's kind of getting to be a mess, We've got 10 petabytes of data now. Do you think one of the librarians could help us sort this just a little bit? And of course, the librarians come over and scream. You're like, dear God, why didn't you call me when this project started before you made a mess of all of this stuff? But we often see thinking about disciplines needing these things. And so from an investment standpoint, where should we think about what really is cyber infrastructure? Do I draw the line here and say, I'm going to provide as common to any discipline on the campus, any research project, this stuff, maybe even unmetered, common funded in a way that you take it, you innovate, you run with it as much as you can? Or do I draw the line up here and say, no, I'm going to go up farther. Search, retrieval, software maintenance, curation services. We're going to make this the cyber infrastructure line, the common good across a lot of these disciplines, so we don't get hit one off in trying to build these things, server rooms in what used to be janitor's closets in various buildings that have heating incidents that may affect multiple buildings on campus and things like that. So from the campus view, I want to move to something that looks more like this, where I buy and provision with pennies from the National Science Foundation or NIH and others. I start to put things together that are common infrastructure. So when a new research project comes along, for example, one of our leading research projects right now is a project in ethnomusicology. A humanities researcher and her team out trouncing around in Africa and other places, taking high-def video of music and performance and ceremony, and they've built very sophisticated software tools for coding. Like, you want to search for round drum, Southern Africa, and wedding. It will pull up a video of a wedding with a round drum and someone, in Southern Africa. And what was really cool was watching our physicist at the cyclotron go, you know how to do that? We video our experiments, and we don't know how to do that. And so when you have a humanities researcher tutoring a physicist, the world is at an inflection point in some way. Okay? So we'd like to get to a view that looks a bit more like this. And I don't know how far up the stack we go, but I do know we've been thinking a lot about networks, and we're thinking about buying storage. But I think there's a lot of value in going further up in curation services, metadata services, and even things like software sustaining services over time, where you could build. It's hard to go hire an industrial strength veteran Java dude who could really mature your software on a project by project basis. You go, look, I got 9 months of funding. Could you come work for us? Maybe in this market, but not typically. Could we put together an aggregated shared service in that area? Question or comment?
Yeah. So looking at this is a very campus-centric view. I don't see anything here on going out, dealing with others, because for a lot of the scientists, the campus boundaries are sort of irrelevant in most cases.
I take your point and I celebrate it because, frankly, I think the very notion of genomics is not the discipline of genomics is multi-campus.
But your computer storage is very campus-centric.
Not necessarily. That storage, if you think of it in terms of an abstraction, it may be some storage provisioned here locally. It may be some storage that comes across TerraGrid. But what I don't want it to be is a bunch of 200 terabytes for each separate research project in a closet somewhere. If it's for archival and long-term storage, they may need local storage for a purpose.
Maybe they have storage that you cannot support, and they are doing something different. I think that taking here this campus controlling everything here.
There's a nuance of word in campus controlling everything or campus offering to research projects.
Then you should show the other pieces as well, that they can exist.
We'll pass out the 3D glasses, and I'll do a multi-campus view of this that will come out. Comment here.
So one of the things is, there is partly hardware here and software. I think that needs to be, considered when you're saying what is this infrastructure. Cyber infrastructure could be cyber resources,
Mm-hmm.
like networks and hardware and computers and so on and so forth, and then cyber software, which is different. I think this workshop is mainly on the software. I may be wrong, but I think that's what it is.
No, it very much is. And one of my questions is, and I didn't draw this in further, but at some level of abstraction, maybe the word campus here is troubling. Take the word campus off if that's helpful. Should we consider some sort of a shared service that it may be hard to aggregate enough programmers and QA testers and everything for a particular discipline, but in getting to scale and leverage, we might be able to do it for more than one. Maybe one of the opportunities of the workshop will be to fix this picture. Let's go here, then.
So I'm not quite sure if we're getting hung up on that diagram before, but this is one that recurs frequently. I've drawn it several times on notice boards around Europe. And the issue here is, where do you draw the line between what is the shared infrastructure that's the cyber infrastructure and what is the domain or community specific infrastructure, cyber infrastructure, that community maintains and plugs into the generic lower level infrastructures. I think this is one of the highly relevant questions that hopefully this workshop will start to address as to which bits of that stack are our shared cyber infrastructure problem and which are not. Because again, that decision process then pushes it into the community space rather than being our space. And I must also congratulate you on finding something that's a physicist not knowing something. That's a real achievement.
You're going to pass the mic on down. And I will say a couple of other points about this. Different academic disciplines are advancing in their use of cyber infrastructure at different paces. Physicists may be way out there. Maybe performing arts are just now starting to do some of those things. So there's a different pace of maturing. And where that line goes, I don't think you can take 200 disciplines and draw the line at the same place across all of them. It will vary some by discipline.
I guess I have one comment. I love this chart. It's actually great. And I think Purdue, we do something similar on the bottom line and share clusters and environments across disciplines. But I think a key element of if you want to focus on campus, various elements of campus capability should be focusing on one of those columns end to end, actually demonstrating that an infrastructure is not something that just relies on some poor physics professor in his lab and his graduate students, but really enables that person then can serve the world or whatever his world is in an end-to-end way, rather than being stuck with, no, well, you get to use software X and go ahead and integrate it yourself.
Fair point. Let me press on, and we'll see if we've got time for more questions as we go. So I think this brings us to the notion, and I heard this talked about last night a number of times, that I'll start by calling the software sustainability chasm. So if you were to assign letter grades right now, in the concept space of thinking of new software and incubating software to get it started, what kind of letter grade would you give us as a broad community right now? Are we doing great at this, or is this an area that's really bad and we need a lot of work for? We'll do a kind of a thumbs up and kind of like middle or thumbs down. You got a middle, it's got a low. Wow, a real smattering difference of view in how well we're doing it at even the concept and the incubation stage. Second,
I think the right audience will be the actual users, the community.
yeah, the users and what they think about
We
it.
can do whatever we want, but they will tell you that your software sucks or it doesn't work or it's not enough or whatever.
Shell?
I think sustainability in silos isn't sustainability at all. There's a question of scale here that is a big part of the problem. So, learning from popular innovations of sustainability is very, very necessary and helpful. But until we can scale it to any degree, I don't think we're going to break out of the problem that we're in.
So for the projects that we have started, someone has incubated it, somebody wrote some sort of package that will, parse genomic sequences, or we'll do physics calculations, or we'll do something of interest. How are we doing in distributing that software, making it available to others, and a process of enhancing it? Is that a thumbs up or a medium or a no? Yeah, that's a pretty low rating across the board. I can't wait for my next question then. Okay, so the next one then, what about the elegant part of software? And that is documenting, doing quality assurance work, code scans to ensure there's no patent violations, things like that. How are we doing on that? Okay, now I've gone to 2 thumbs down. Okay, so the challenge is, when we think of this, I actually think, maybe for seeing new things start up in concepts, we got this shotgun approach. We got lots of that out there. Some of it makes it through vetting for NSF funding or funding from the Hewlett Foundation or others. But in general, getting to from version 0.1 to version 1.0, or maybe even during the life of a grant to version 2.0, we've at least got something going on there, even if it sucks. We've at least got that together. But almost all the grants that are written, we feel obliged by the funding agency to write a promise. And at the end of this grant, we will build a software community that will sustain this forevermore, right? You can't send a grant to the Mellon Foundation without asserting that to be true, whether you believe it or not. And NSF wants you to think that way, that you're going to have a sustainability plan. So we think of the chasm, the holy grail out there. How will we cross the chasm to sustaining? And we start worrying about that somewhere along the way as we go through this release 0.1 up to 1 and release 2 and such. But I think this notion of sustaining, just as you see on the slide here, maybe it's actually a mirage. That it's this thing off in the distance that feels like it's always just fading away from you as you chase it, because you don't actually go through these stages. What you find is you have release 2 and release 2.1 and then maybe release 3. And if we think of dot releases as improving the current one, and maybe a release 2 and 3, some plumbing changes, big framework changes underneath, possibly. But how are we going to fund this one? Because maybe we go back to the granting agency and they say, okay, I'll put another quarter in the slot machine and pull the lever one more time and see if a jackpot comes out. Or maybe within our own campuses or our own research projects, we find some means, but even if we succeed there, then we really just have release 4 and release 5 if this is going well. And as John Madden famously said, if you're going to participate in sports, you got to be ready to sustain the celebration. You see these guys all get pummeled and tackled after they catch the ball in the end zone and almost get killed and injured in the celebration. So if we actually build something good and the community does pick it up and it makes it from release 2 to release 3 and to release 4 and all, what is the means of seeing it all the way through, even into the ultimate life cycle of rest in peace? Can we have purposeful mercy killings, or does it all just have to atrophy until the end? So I've started thinking about the chasm is not what I showed you at first with the magic word sustainability out here. The chasm is really a loop, and that is, how do we ignite and sustain loops that can go through these? And they're not all segmented. It's not that when we begin work on release 2.1, we're still often patching and sustaining and supporting. Maybe release 1.5 was the one that everybody thought was golden and really started using. And while there are subsequent releases, people are still heavily in 1.5 because they can't move off of 1.5 until something else happens. But when they want to move to version 3. They don't even want to make a jump to version 2. So this stuff is concurrent. It is not as beautifully sequential as presented here. So sustaining seems to me more about sustaining loops than it is about getting to an end stage in some way. I wonder, for us, in thinking about software as an artifact, are we nearing our derivatives day? And I don't mean derivatives in the elegance of mathematics. I mean it in the scandal of finance. So the Washington Post ran a superb story as the financial meltdown started in the earliest of days back into August or September. And they traced it all the way back to the origins of a conversation with Alan Greenspan and Bob Rubin here in the United States, Secretary of the Federal Reserve and Secretary of the Treasury, and the Clinton days. And the view was, well, we don't really understand derivatives. Let's let the market work. We shouldn't overregulate these things. They may be a new means of creating value. If we try to regulate it, then the Europeans and the Asians will do it, and we'll miss out on it. So let this thing run for a while. Well, they let it run for a while, and then they actually passed a law in the early 2000s that said you can't regulate it and let it run. And so we ended up with an industry that ran completely off the rails, as you know, and created enormous systemic risk throughout the entire worldwide financial community, and particularly the U.S. financial community. And so I wonder, and we think of this whole thing called cyber infrastructure, and software is a critical piece. Research and scholarship are being advanced on the back of the tools that we are making available on workbenches and being shared in disciplinary communities and such. Are we nearing our derivatives day when the systemic risk involved in how we are seeing, maintaining these tools, we're going to have that meltdown where papers were published about health and research, and then we find out there were huge bugs in that code from some time ago. And no, it really wasn't that gene, it was the other one. You've been turning off the wrong one. I exaggerate slightly. But, you know, are we facing some systemic risk? And is our derivatives day near? So I was very heartened by this book. Perhaps many of you have seen it. Stephen Weber's book, The Success of Open Source. And in this book, Weber writes, he does, I'll call it like anthropological study. He's a political scientist. And he does a study of the Free Software Foundation, and then Linux, and then Apache, and some of these as they went along. And one of the things that he observes, because the central challenge is traditional computer science literature and research about how large, complex software is maintained says you can't do it in this ad hoc way. It needs more coordination and control and top-down planning. But yet we have Linux and Apache thriving, so something's wrong here. What's the disconnect in between there? And we started reading this book in the early days of the Sakai project, and it was very comforting to us because one of the conclusions that we reached was we didn't have to do Sakai right. There wasn't a way or a model out there that, oh God, now what was the cookbook Linux did? Okay, we do step one, and then we do step two. Oh wait, no, how did Apache do it? You know, Linux partially succeeded because at a moment in time, they rejected some of the approach of the Free Software Foundation and had a blow-up meeting and did some things differently. Likewise, Apache partially succeeded because they chose some very different paths than the Linux community did. And so the lesson is, it's not about getting it right, it's about getting it right for your community. So you have the world of lessons to draw from in fitting a model that works for your community. Koali for financial and administrative systems is different than Sakai, how it does for teaching and learning. It is different than several of the library systems in Fedora or DSpace. So it's really about learning the lessons for your community. So we know these models of distributed development work at lower levels of the software stack, but now do they work for maintaining applications, particularly applications that may have very narrow audiences? It might be an audience for life science research, or it might be an area just for cancer research of a particular kind of cancer, or just a particular area of astronomy, not even astronomy writ large, just a nuance of astronomy. There's a tool that we're trying to maintain. The second book that I recommend to you, if you've not read it, is one called Dreaming in Code. And this book, about a third of it is reviewing a lot of computer science literature, and a third of it is ethnography embedded while it was happening in the development of Chandler, which is a project that stalled pretty badly, I think is a fair statement. Is that fair? Okay, and it had Mitch Kapoor leading it, of Lotus 1-2-3 fame, and the author was given complete access to everything, attended the meetings, read all the email, and he chronicled what happened and part of why that thing fell in the ditch, and where some of the vision was wrong, where the money was wrong, where the personnel were challenged. It really is very telling. And then the last third is the lessons learned from it. So to advance our conversation this morning, I want to offer 3 C's. I think finding a path forward for us, and I do not believe, and I want to be real clear about this, and this goes a little bit to some of what Gerhardt was raising earlier, and several of you. I do not believe there is the way for software sustainability. I think the way to sustain software that is critical infrastructure, maybe middleware kinds of pieces that are broadly used, may look like this. And the way to sustain software that is unique to a broader area of a discipline or a couple of disciplines, it might look like this. It's a little bit different. And the way we sustain a tool that has the most narrow but critical of audiences, it may look different yet. So I think I expect we're going to end up with some kind of a contingency view that there's more than one way. But I ask you to think, are there 3 C's in each of those types of sustainability? And that is the code, coordination, and community. To first order, many of us, when we think about models of sustaining, we reflect on Eric Raymond's classic comparison of the models, the cathedral and the bazaar. And what we often note, if you've been a part of a cathedral, the big top-down software, typical corporate model, is you just scream about the bureaucracy and the morons making decisions around you who can't clearly see what should be done, and you long for the bazaar, the individual action where you could just do it and just make it happen, and the lawyers wouldn't help, and you could just move on. And then if you're way down here every day and you're in the bazaar, you look longingly at the cathedral at the end of the block, and you wonder what life there might be like, because all of these morons around you, they just won't coordinate and work with you, and no decision can ever be made, and meetings are like Groundhog Day. You relive the same problem over and over and over. So let's take a look and think about models of sustaining the code. And we know that Linux and Apache, they're great out there at the lower ends of the infrastructure stack. They've learned to do it. But the first thing I want to drive home is a point said earlier today, and that is the cathedral doesn't have it all figured out right yet either. So here's an excerpt. I'll let you read through it. Dear Mr. Ellison, an angry letter was written and published to the world. It essentially said, no, I don't want to move to the sucky product that you're trying to push us to. Would you just make the one that you sold me the first time work? And I want to continue on it. I'm happy to pay you for it. And but I'm probably not going to do what you've got a pitchfork in my backside trying to make me do, because your interest and mine have diverged. So the corporate model for sustaining the code is a bit of a challenge. The user community often doesn't like where that model may go over time. I think you can all draw some recent observations yourself from that. But the open model for sustaining the code, one thing that is really great is it is the shortest path between a user and a developer. So here's just a quick excerpt. One day, someone on one of the Sakai lists said, I'm writing the code where we resequence and reorder how resources appear. There's a tool, it's the big file manager, the resources area. And I'm thinking of a couple of options here. Posted a question and look at the time and the comments flowing in. Within just a couple of hours, a broad community had chimed in and said, make it sort to the left, make it sort to the right, whatever the conclusions were. Now, the developer drew his own conclusion or whomever he was working with, but that immediate feedback, how do you even get word in to a developer in a cathedral model? They're often 3 layers removed and you can't even get word in. We know we've got a challenge with code evolution. How are we going to continue to maintain an authoritative release as things go forward? Because that authoritative release, if it's being done well, maybe it has gone through rigorous QA and quality assurance work, and we can have confidence in it. Maybe our attorneys at our institution won't have to worry that we're going to find ourselves in a lawsuit because it's part of, some other problem along the way. What about code forking, where developers go, no, I don't like the way you're going, you're wrong. The web services interfaces are evolving in a different direction and you're choosing the wrong standards, and I'm going to fix it, and I'm going to take these 12 people over here with me. Ultimately, questions of maintaining code very quickly turn into questions of how will we coordinate and how will we manage community. Now, whether that community is a corporate model or that community is an open source model, it's community in some way of how we're managing it. We have to right now be doubly aware of the killer software patents. Those of you who track the Sakai project, Sakai became an alternative, perhaps some would view as a threat to Blackboard. Blackboard had about 80% of the U.S. software market. I'm sorry, the URL here is not responding, but in the greatest of American capitalism, they responded by suing. They didn't sue the Sakai project. They just wanted to create fear, uncertainty, and doubt about the risk of taking that dodgy open source software. So they sued the number 2 company in the market and have drawn that out now for 3 years in just a FUD campaign. So one of the things that we've done in Koali in our releases is paying for code scans. There are those companies out there, is it Black Duck and several others, they've essentially got the Turnitin software plagiarism detection that will go through and check your code. One of the things I was very pleased, the first scan of the Koali financial software, they said they wouldn't name names, but we came back cleaner than most of the commercial code they scanned the first time. So this is another area with the code. How will we coordinate? Isn't that really part of the problem? Sometimes we use money as the surrogate for coordination. If I've got money, I can pay you, or I can pay my graduate students or professional developers, and then by authority, I can cause something to happen. If I don't have money, how do I get you to do the thing that I need you to do because I don't have the ability to do it all myself, but I know you know how to do it, but your agenda and mine are not aligned in what's going to happen with that. So I raised a couple of coordination models, and this is one that we've talked about a lot. And I think the models have to evolve at different chapters. So there is the time when we're creating software, and then there's the time when we're trying to sustain it and move it out. So the classic means of coordination, the cathedral model, is everybody paying some licensing fees, everybody paying some maintenance fees. A company will coordinate for us. They'll do the requirements gathering, they will adapt the software, they'll do the quality assurance work, they will provide indemnification or claim to, that in case you're sued, that that they'll take the first bath on that. And this is all bundled together. The problem that we find here is sometimes this gets us into a monopolistic situation where we get some software, we buy it, we like it, we train people to use it, we get it embedded in what we do, and they go, we're going to have a price increase next year. And you go, we don't want to pay more. And they go, that's okay, just stop using it. And there's no alternative. So you pay a little more, and then what happens a year after that? Yeah, Daddy needs a new airplane. Okay, so another and we see especially where there are switching costs in software. So an alternate model is, what if we coordinate ourselves? One of the key differences is the intellectual property in In this model, source projects find a way to gather people together to launch one. And then here's where we're often at. This is that sustainability chasm. We're trying to figure out, okay, then what the hell do we do? We've built this thing. Now how do we keep evolving it to release 3, release 4, and sustain it in some way? Well, one of the things that we've been doing with the projects we've been involved with is building a membership-based partner model. And so the rules are the software is open. Go download it, use it if you want. Or you can have those benefits plus pay $10,000 or $5,000 or some fee to be a member of the foundation. And what do you get in being a member of the foundation? You get the ability to use the freely available open software. Now, how's that for a hell of a value proposition? So you worry about the free rider problem. So how do you manage that? Because this model has a gate. You don't use it unless you pay. This model, broader adoption, because there's no gate, it costs to install and support software. But how do we make that work? And so this is one of the core things that we're wrestling with. Shell's on the Koali Foundation board. I'm on Sakai, was on the Sakai board now. Koali is there something about this model we can figure out a way where small money voluntarily paid by a lot of people rolls up sufficient resources to continue the software. Now, at present, there's a nuance here. We are not trying to roll up money to have a central development team and a central group that sustains the software like the commercial model does. We're just trying to roll up enough money to coordinate development that's still going on at the edge. Conferences, workshops, symposia, and some coordination of architecture, paying for those code scans, QA work. A lightweight model, not a heavyweight model. The other thing is we view it as a competitive market space. There are multiple companies competing to provide aftermarket support installation for that software. The problem for the topics that we're dealing with, in many cases, there's not a large enough user base for there to be a real functioning marketplace of multiple companies investing to build out those skills. So you may end up back in a monopolistic situation where there is one support provider, but if you've always got a walk away right, then to open code that may be supported through the community or otherwise, it's not the same pricing power that a monopolist provider has in the maintenance fee section here. So,
Before we move on to that,
yeah.
that last slide, one of the challenges also is the perceived incompatibility between the two models. The commercial software sector, where we want to see full integration with the community source sector, has not yet figured out how to do so without feeling threatened by the community model. And the community model is not able to thrive to the same degree where we want to interoperate with many of the commercial products. I think that there's a thicker line there in the middle that we want to see bridged over time, because there's opportunities for the commercial market to continue to evolve and advance at different paces with different market segments than the community side. But I think one of the challenges is, in terms of sustainability, they're not on the same path, and we can't figure out how to bridge them.
I think that's right. I probably should just draw a big chasm in between this. But even yesterday, I was reading a comment by one of Microsoft's many vice presidents saying, look at what we're doing with open source. We are opening up to build connections where there's a Linux environment out there, being able to plug in and talk to Windows more directly. Not fully there yet, but starting to argue a little bit some encouraging trends about bridging that as they go. So when you look at, this is a software project. That's the Koali financial system. Koali in total right now, across Shell, about 5, almost 6 projects, a little over $55 million of investment, and about 8 of that from a foundation, and the rest of that from universities themselves, putting cash and staff into the project. So a fairly large cathedral-like looking organization, isn't it? We've got the functional council, we've got the technical architecture committee, there's subcommittees who are doing things, there are project plans. You can know the release date is going to be on July such and such, where in a pure open source model, the release date is when it's done. That's when it will be released. And that's hard to plan around sometimes. Now, this is just the financial system. There's one of these that even looks much larger for the student information system, and another one of these for the research administration system, and a couple more starting up for smaller projects. And a year ago, last summer, we thought the Koali Foundation for sustaining all these different projects, and trust me, when you talk about research administration people and finance or student people, they're about as correlated as, the performing arts and astronomy. I mean, different worlds, completely different worlds. So about a year ago, we thought the Koali Foundation was going to be a multi-project entity that would be like Koali Foundation here, and there'd be the finance project and the research project and the other project. And the foundation would provide a lot of shared services. And last summer, we decided that was the wrong approach. We changed the model. We've decided the Koali Foundation needs to be a fairly lightweight set of shared services, and the financial project is larger, and the student project is larger. So there's just a common number of things that they all need, but you can't get all of those projects to start paying money into the center saying, trust us, we will do good for you. In time, that will fly apart. So the money, by and large, stays in the projects with just enough money in the center to not have to reinvent the wheel and coordinate shared services. And this is really, I think, one of the questions that we're all facing. If we think of system lifecycle, if I'm doing it by myself to build a project on my own, the life cycle cost of maintaining it over the years is fairly high, but the coordination cost is very low because I'm coordinating with just me or my team. But can we drive down that life cycle cost by more people investing, a few more teams being brought to bear, with the coordination cost not, swamping us? And we think somewhere there's a magic point here where it's probably hard to keep driving costs down much more, and dysfunctional, it just starts going up. And we've really learned to vet partners. There's a dating process. We got to go out with you a date or two before we'll kiss you in terms of deciding if your institution could or should invest. Some personalities are toxic. And Koali, we've actually learned how to throw people under the bus to the celebration usually of the whole project because you've got someone toxic involved. And I think it's an important thing in learning how to do this. Also learning how to synchronize. Maybe Michigan does not need research administration now, but they're going to in 2 years. Maybe Indiana needed it last year, but we've been holding our breath. Can we pull our clocks together so we can pull our money together? So it might be that there's a couple of projects out there. Physics doesn't quite need it yet, but biology is hurting for it. Is that a role for the funding agency to see those needs and help maybe synchronize the clocks a little bit in pulling some money together for it? So in the community, code coordination community. I'll be brief here. There's probably strong views in the audience on this, but one of the things I definitely believe is your choice of licensing. It helps to shape your community. And licensing, we could spend days and days on this topic. I have a few veterans of a workshop we had here on licensing, and we actually came out with a framework for software sharing and licensing after I thought there were going to be murders in the room. But in a continuum from a GPL, GNU style license, to BSD style at the other end, we all know some of the rules around that. And I do think there is a bit of a middle place too, that we can do a licensing regime that the commercial world doesn't worry about commingling that code, and the commercial folks will come in with some joint investment with it, but still in a way protect our future, that we don't have to worry, we're going to write some code, someone's going to take it all away, and then we're screwed. I think licensing does tell us a lot about the kind of community that we're trying to build. So between that cathedral and the bazaar, I think is the place we really all want to be in finding our model, and that is what I'll call the pub. Okay, we'd all like to gather at the pub, and we're referring to this as a community source model right now, that it blends elements of a pure open source model and how the code is released, how the CVS tree is maintained, how QA is done, how it's distributed, how the requirements are distributed, but it also brings in some elements of the cathedral. Some project plans, some shared budget, some authority, and finding ways to blend those two. And I don't think the community source model is there is the way, as much as it's an area in between saying you draw different elements of different models that suit the community that you're trying to serve. And that's the lessons and where we've been working on. So I'll wrap us up here saying this might be one way we think about some of our conversations. That is, if you list some archetypes of models here, and there's lots of shades of gray in between here. I've just put a few categories in. Homegrown, local, heads-down projects, stay the hell away from me, but now I'd like to share, can you help? All the way over to a commercial model, which in its extreme may have a proprietary license that doesn't allow you to use it. And I know we think some of our projects, they may just be license transferred, sold to a company who will then provide support and maintenance, and they can put a toll booth in and people will pay them. And then even this whole space here in open source, from the organic, what we'll call just the pure techies view, maybe lower in the software stack, to maybe the suits and funding agencies or CIOs view of saying, no, I need to know when it's going to be released, I need to know the code is clean, I need some assurances. What are the elements across these about how we sustain the code, how we coordinate our work, and what is the nature of our community? Will people opt in and work voluntarily in that community? And I don't mean funded by their employer, but they view it as self-actualization in some way of participating in that community and doing it. Or can we make it palatable enough that a PI or a department chair or someone in a company, they will allocate paid staff time to work in the community, not under the direction of their manager, but just doing things that need to be done in the community? Or to what extent is it we just need to hire someone? Can we get a team in here from whomever, IBM, and they will take on running this part of it and hardening this code and optimizing it to work better? So maybe this provides us a basis for having some of these conversations. Because I think fundamentally at the end of the day, we are dealing with a resource allocation problem. Whether it's personal attention and passion, or it's NSF money, or it's campus money, whatever, we're dealing with a resource allocation problem. In my view, we're doing good or doing well at the edge. We got a lot of innovation going on. There's a lot of things tools are being made for things that researchers need, problems that need to be solved. The edge is working reasonably okay, but the edge is incapable of sustaining hardened cyber infrastructure over the years. So what we've got to find then is a way to pull back and find some leverage. Because hardening and sustaining this stuff, we can't do it just in the biological sciences. Some of the tools that we need and the money we need for hardening this is going to have to be leveraged across multiple disciplines. We're going to have a utility in some way to leverage. But the missing element between edge and leverage is often the greatest challenge, and that's the social engineering work. How do we get to trust? Because if we got leverage, let's say we build a software sustaining utility. Jennifer goes back and says, I got an idea for some of that stimulus money. We're going to put X dollars into the software sustaining service of NSF. And so when your project is good enough, you've hit metrics that umpteen thousands of people are using it, and it's being deployed, and it's made it over some hurdles that it's for real, you can be promoted into the software sustaining unit, where we have engineers just standing by, ready to take your suboptimal code and fix it and make it work. Now, are you ready for a behavior change? Do you trust trading it, that handoff? And what about the people here who would start working for that utility? Would they always get to the point of, ugh, those people at the edge, they write crap code. They don't know how to optimize any service interface. Why don't we just do it ourselves and cut them out over time? This notion of edge, leverage, and trust, I think, is part of the problem that we're going to have to figure out as we balance these things going forward. I'm not worried about the edge. I'm worried about the leverage and getting the edge to take advantage of some means of leverage if we find a means of building it. I hope coming out of this workshop there will be some serious proposals about how we might build some leverage to harden the things that we want to sustain over time. I realize there's a million questions in that. What are the things? And what does sustain mean? That's what we've got a little bit of time to talk about. So we find a few discussion questions here, and we're out of time, so I'll just pose those as, do we need the Linus Torvalds? Do we need the semi-benevolent dictator on some of these projects? And what's the authority if we're going to have that? Is there going to be money? Is it going to be your project isn't certified, and ultimately if you don't have the good housekeeping seal, other places won't want to make use of it? How are we going to do some of this hard stuff, the QA, the code scans, et cetera? Are we just in a transition model, or is there one out on the horizon that we can really work towards? One model that has been proposed, and this is my last slide, was a 2004 essay in the Chronicle of Higher Ed. One of our colleagues who had been a CIO now at the Mellon Foundation, Ira Fuchs, said, do we need EduCore? And EduCore was his concept, essentially like the old Bell Labs, Bell Core from when you had the AT&T Bell companies. For those of you not in the U.S., we used to have a lot of different phone companies, Northeastern Bell and Bell Atlantic and such. They were all owned by the same parent. And there was a shared service that did engineering and research work. It was Bell Core that shared that, and then they would share that innovation back to all of them. So then, of course, we broke that all up because of deregulation. It took 20 years, and they all bought each other, and we're back to one now. But the question was, should we have an EduCore where there is money that comes in off the top in some way from funding agencies or campuses, and you roll up an annual budget of, let me just make up some numbers, $10 million a year or something like that, and it has a staff that can do some of these things over time. Now, this idea, when Ira published it, he had to have a bodyguard and travel in an armored personnel carrier afterwards. Because in 2004, this was an affront to the edge. You're going to kill innovation, just et cetera, et cetera. And the idea just died right away. But it's slowly being resurrected as from the bottom up, we've realized all the problems he was aiming at trying to solve. Not exactly the way he proposed it at the time, but that's one thing. Possibly we need some shared service who can take on and do these things. We're out of time. I think we have a break coming up. I'll be around the entire couple days for questions. I'll be with you in the breakout groups. And if nothing else, I hope this has provoked a little bit of thought as we move to our next session. We do a break and then come back. Is that right, Craig? Twenty minutes. Okay, thank you very much.